Hi, everybody. This talk is going to be a brief history of the Kubernetes fleet controllers and its essential features. And basically, we're going to try to understand how we can master fleet management of Kubernetes clusters through open source. My name is Mickael Alliel, and these are some of the things we're going to talk about. So I'm going to introduce to you what even is the problem, because there's always a problem. But then also the difference between what is a DevOps engineer in regards to the differences with being a DevOps or a platform engineer, what are fleet controllers, how open source fits into all this picture. And we're going to do a small comparison of all the trends and history around fleet controllers and the open source community of Kubernetes in that regard. And I'm going to give you some pointers on how to master all of that. So first of all, who am I to talk about all of that? I'm currently Ops and Backend Tech Lead at Komodor, where we do a Kubernetes management platform. And I'm a very big believer in empowering developers to move fast and keep a very high standards of quality. So I've been using Kubernetes, and I saw it change around all that time, about 8 years that I've been using Kubernetes. And let's start. So first of all, I believe that in history is always some kind of story. And in every good story, there's always some kind of protagonist or heroes. So in our case, there are cloud heroes. So our journey begins with having a great idea. And we want to turn that great idea into a reality, in our case, an application. So after a while, it became so successful that our team of heroes needed some kind of extra oomph, and we needed to scale that application, right? We start low, and then we want to bring that application to a wider audience. So we do that by, in this case, migrating our app onto Kubernetes. Great. So at first it was very nice, and then it kind of turned into chaos very, very fast, which resulted into our platform engineers or DevOps being a bit depressed, and we don't want that. So what happened was there was a big difference between managing or having just the one cluster managing your application rather than having tens or hundreds or thousands of clusters managing either the same application in different environments or just multiple applications because your business grew over time. And as we can see here, there is one very cute cluster, and then what it transforms into when you have hundreds of them. This happens every time. So the problem we have with scaling Kubernetes into very, very large numbers, there's a lot of them, but the most prominent one, I think, is the moment that you have a small amount of cluster, you're used to doing things a certain way. And then it turns into hundreds and thousands. And the way you used to do things when you are small or when you have a small amount of clusters differs a lot from what you are supposed to do to be able to maintain the scale of having a 3 or 4 digit number of clusters. And then all that routine maintenance that you used to do to keep everything healthy and everything running smoothly becomes an annoyance because you have to do the same exact thing 100 times. Or then it doesn't work because one of your cluster differs just a little bit, right? And when you work with large numbers of anything, not just Kubernetes, you start to encounter also very unique challenges or edge cases that you just don't encounter when you have just one thing and it works, right? And so when you have a lot of things, again, in large numbers, everything is so similar, but also different at the same time, right? You might have 100 clusters doing the exact same application, the exact same thing on different cloud provider, different regions, different scale, different whatever, and there's always going to be a little different thing. So if we go back a bit in history of Kubernetes, right? Kubernetes has been around for maybe the better part of 10 or 15 years. It started getting traction a lot in about 2014, 2015. And this is a screenshot from the Wayback Machine that kind of gets archived of all the web pages back then. And the earliest one that worked for me to get was 21. And then we can see, I don't know if it's maybe small, but the cloud-native interactive landscape of the CNCF. And that shows a little bit about all the different projects that the CNCF supports and everything related to Kubernetes around that time. And this is it right now in 2025. And while it looks pretty similar, it's also very different, right? There is the same kind of categories that the CNCF wants to support and adopt, but they shift in that way that different categories such as orchestration infrastructure or applicative or networking, different things at different times gain traction and are gaining more interest from the community of Kubernetes. And so if we go back every year and we look at that, then we can see that not only the orchestration and infrastructure is always a very large core pillar of what the Cloud Native Foundations wants to support and the community has interest in, we also see that it grows in numbers, right? There's more and more projects growing with each year with Kubernetes. And sometimes you see some of the large projects just staying there strong, and sometimes it just changes, right? But this is just to illustrate the amount of existing tooling and technologies that we have available to us that can be part of our cluster or part of our fleet that your organization might be trying to use to keep things consistent and maintainable, right? And some of the ways that that we encounter issues when managing a large amount of clusters in our systems. One of them is that observability is very important, obviously, but it becomes more and more difficult to kind of keep consistent when a system is very much distributed and it's kind of growing and spread out over multiple places. Security and access control becomes even more problematic, not only in terms of the application and business, how you get your user access to your application, but also how you get your developers in your organization access to the infrastructure, to the clusters. And once more, when you handle 10, 100, 1,000 different clusters, and your organization grows in size as well, you're having more and more trouble having kind of the least privileged access for any individual. But then there's also the lack of expertise to manage all of that infrastructure, right? So from a very, not research, but from what I know from my experience, the larger your organization is, the less amount you have, the less amount of people you have that actually know what to do with Kubernetes. And so when you might have 10, 20 developers in a startup company, then you have 1 or 2 people that knows Kubernetes really in depth. And when you walk in a very large corporate organization that has thousands of developers, you maybe have 10 people that knows what to do, and that becomes very inefficient. Then there's also the inconsistency that when you're trying to deploy your app to a production environment on specific tenant or region, everything goes fine. But when you're trying to deploy the exact same thing or same version across different tenants, different regions, then something is just not the same. Some things just stop working randomly, and you have to figure that out. And then there's also the crazy amount of time that you spend just troubleshooting and configuring stuff manually, because that's how cloud providers like to do it nowadays. And at a certain scale, basically, I see that there is a trend to shift your infrastructure and your knowledge from having a team of infrastructure engineer to a platform engineer, right? And it's kind of, I can put that as having look at it the same way that DevOps is the high-level philosophy, right? a bit like agile development, and platform engineering is one of its implementation, right? So you're still doing DevOps, but you're doing it in a different way and empowering your developers in a different way. So there is no conflict in between the two terms. It's just a different way to look at it and a different way to implement it. And in this paradigm of platform engineering, the way I see it is that most of the infrastructure needs should be either fully self-served or fully automated, right? You don't want to do anything manually via a UI. You don't want to start doing manual changes to accommodate every single difference in your clusters. You just want things to be accessible for anybody that needs it. And there is a large process of kind of getting traction and shifting from being from a DevOps mindset to a platform mindset. So a few examples of what I see between the differences between them is that having a DevOps engineer is kind of being an individual contributor, is the person in charge of maintaining like the day-to-day operations, and it's usually a person that does kind of one-off project or one-off initiative, just, you know, we need to do that, let's attain that goal, that's it. Is building all the CI/CD pipelines and kind of firefighting with all the developers that having issue with the infrastructure. As on the other hand, the platform engineer, it's kind of an enabler rather than an individual contributor, right? The platform engineer will kind of manage functionality between different teams and kind of hook everything together. He will be in charge of building self-service capabilities so that the developers can then do the work of a DevOps without being a DevOps. And kind of the ongoing routine of enabling and managing the platform as a whole and not just the cluster as an application, as a one thing, right? And with that in mind, we have a new concept, something called the fleet controller, right? So it's a new category of tools, and it's sometimes called a multi-cluster controller, sometimes a cluster fleet controller, just a fleet controller. Basically, it's a system that is designed to manage multiple Kubernetes cluster as a single logical entity, right? And it's our way to centralize everything that we need into one place to be able to manage it more efficiently, right? So that's something that's going to address the complexity of everything that we talked about here, right? And out of a fleet controller, what we usually want is something that allows us all of that, right? Registering and keeping track of all your clusters, propagating all your workloads, basically all your applications in an efficient way that is organized, managing policies, whether it be permissions like RBAC, or just policies in terms of validating that everything that is being deployed to the cluster is something that your organization is overseeing in some way. It should have a declarative approach, integrated observability and metrics, lifecycle management, failover, high availability, and not always that's the case, but in my mind, if it's open source, it should be agnostic to the cloud provider that you're using, because that's just the way I believe it should be, right? But in short, we really want a way to organize everything and control it via one unified platform, right? Instead of having to deal with a lot of different tools and a lot of different clusters and a lot of different environments and a lot of different peoples. Right, so there's been a pretty steady interest over the years, both in Kubernetes, but also with these new category of tools that we call fleet controllers, right? With both new projects kind of starting up and gaining momentum, but also just old projects that are going to stay there for some time, right? So right now, I'm going to take a few of these projects and kind of analyze what they bring to us and how we can basically quantify and understand what is the best product or the best project for us to use if we want to manage a large amount of clusters. So our focus is going to be around open source, We will focus exclusively on open source for this analysis, and that's to ensure both clarity and reliability in comparison, because it's harder to compare between an open source and something that is a paid product, obviously. But we're also at an open source conference, so that makes sense. And the way that we will measure success is basically taking some of the key metrics that we base open source on, right? So GitHub stars, activity around commits and engagement, community engagement as well around different Slack, Reddit, forums, GitHub issues, pull requests, stuff like that, and also the momentum that this project is growing at, right? So it can grow very big, very fast. It can grow over time, and we're going to take each and one of these projects and kind of just at a quick glance try to compare them and see the differences between them and what the community actually likes, right? So we're going to talk about 5 different containers or projects: Clusternet, Karmada, Crossplane, ClusterAPI, and Rancher. Anybody in the room is already using one of these projects? All right. And we'll start with, I think the order I put that is kind of the smallest one to the biggest of them all. The first one is called Clusternet, and basically they market themselves as something that helps you manage your clusters like the internet. And basically it's a very general purpose system to control different environments as a single plane. It's a project that is supported by the CF Sandbox, and it's very simplistic in its nature, right? It just gives you kind of built-in permission and multi-cluster management, but that's pretty much it. It's just a way, if you want something very fast, to kind of manage a lot of clusters at once. And this project has not been the best in terms of engagement. And we can see that since its inception, over time, it just started drastically going down and down in terms of activity. And as you all know, if something is not actively maintained, it's very hard to kind of get the buy-in to actually use that product. Second one is Karmada, the Kubernetes Armada. So Armada is a term that basically means a fleet of ships, if I'm not mistaken. And that's a cute play of word for Kubernetes. But it basically, same thing, enables you to run cloud-native applications across multiple different tenants and Kubernetes clusters, different clouds if you want to, without really touching any of your business logic of your applications, just infrastructure, and provide you the automation needed for all of that. And some of the nice things about this project is that it's very open and neutral. You're not locked into anything. You can just start using it at any point in your process. You can just drop it and replace it with different things. And this project is a little bit larger in scale and provides you more data or more features, such as scheduling different failure recovery procedures and traffics, and just policies around a lot of different stuff. So it still has a lot of contributors. It's kind of staying the same way. But around the community itself, GitHub is not the only thing that matters. And there's not really a lot of talking about Karmada, from what I saw. Next one is going to be Crossplane. So Crossplane was very, very ambitious in that it's not really trying to be the one thing that you will need to manage your multi-cluster or fleet of environments, but it's trying to do that for everything that you know, right? You want to manage a lot of different API versions, a lot of different applications, some custom whatever project that you have in mind, then Crossplane will allow you to do it, right? It's very extensible, it's kind of a plug and play. It builds on top of Kubernetes and allows you basically to orchestrate anything, right? So the way it works is basically a bunch of CRDs that kind of plugs in what you already have, and you can build yourself your own fleet orchestrator or API orchestrator. This is a project that had, I'm missing some of the metrics, but it's a process that gained a lot of traction over the years. We also, my company, Komodor, developed an open source tool to help troubleshoot Crossplane, and basically try to visualize all of the things it puts together to help you kind of give it an extra kick to what the capability of it can do. ClusterAPI is a bit controversial. It started relatively early in the age of Kubernetes, around, I think, 2018, which is like 4 years after Kubernetes started. And it has a lot of ideas and a very large scope in what it's trying to do, but it just never gained any traction because it's very, very complicated. And even though it's part of the SIG lifecycle, which is like special interest groups of the CNCF, something that the community is, the CNCF itself is very interested in kind of making it work. It's a bit too complicated for people to actually use, and just the traction around it was never one of its forte. But it's also the same, some of the same features allows you to really extend your capabilities around Kubernetes and make it so that you can orchestrate a lot of clusters, a lot of environments very, very easily. So it's still to this day pretty much active in terms of the project, but some people either like it, some people don't like it at all. There's no middle ground about this project. Then there is Rancher. So Rancher is one of the mature one, and it's been around, I think, forever, since Kubernetes was actually getting used. And it's a very complete stack, basically, on top of Kubernetes that allows you not only to manage Kubernetes itself, like the applicative stuff, but also kind of a day zero operation thing, which allows you to just spin up new cluster, new environments, and manage everything related to that infrastructure from their platform. I think the biggest selling point, not saying that some of its features are not good, but the biggest selling point of Rancher is, in my opinion, the fact that there is a very, very large community around it, and it's maintained and backed by, I think it's SUSE, so a big company behind it. It's always going to be supported. A lot of people are using it. A lot of people are kind of invested into it. So that's something that we're kind of looking for when we're trying to choose an open source project. And you can see here, like, since its start, it's been very, very active. It's pretty stable, and the engagement of the community around it also is, as I said, very active. You will find a lot of information, a lot of reviews, a lot of like people kind of giving you their idea of it, and such. So Rancher gained a lot of stuff very steadily, always gaining traction. And Rancher being in green here, you can see that out of the 5 projects is one of the most used, or at least most people click the star on it. I don't know if that's really a metric that is quantifiable as something that shows actual interest, but that's how people see it online. And the other project, apart from Crossplane, I think, so the other 3 projects are kind of starting to die down as time goes on. And we do see that there is a real problem that this kind of category of tools are trying to fix. It's just that they didn't fill the right hole, the right solution. So this is just a quick summary of all the different tools and what they could be good for. So again, it depends if you're trying to find a one-stop shop that is good at doing everything and has broad support, or you're looking for something a bit more simplistic and just trying to have a declarative way of orchestrating all your infrastructure, or you may be trying to extend your capabilities to not only orchestrate infrastructure in terms of cluster, but in terms of anything, like Crossplane does, for example. Right. And so, at least in my opinion, I think that regardless of what tool you might be using, if it would be for fleet controllers or anything else, there's a few ideas or key points that I find important to remember every time that you're choosing such a project, whether it be governance, which is establishing like policies and permissions around your processes as an organization, or keeping things simple and kind of, instead of doing everything yourself as a DevOps engineer or just platform engineer, enabling the work that you're doing to be able to be done by anyone in the organization, having good visibility around all your orchestration, and for most of the stuff to be automated to make it easier and more maintainable at a very high scale. Right. So this is kind of a cheat sheet in how to really master fleet management when you grow in size. Again, it's very high level. It's going to differ a lot from organization to organization, but this is kind of key things that I feel are important in order to kind of be able to scale and have hundreds and thousands of clusters. And I think that's pretty much it. So kind of our journey here ends in mastering fleet controllers, but you might be looking to kind of expand on that in your own organization. I feel that dedicated or new category of tools that is essential, in my opinion, to be able to do that. And if you're not going to choose an open source project, you might be paying for some product, or you might be building your own, which is oftentimes the first thing that companies try to do to kind of save money, and then they realize that, oof, that's a lot of work to build the same thing that like hundreds of people are actively contributing to. So we've explored kind of 5 different projects, and each of them is kind of a unique thing that has a unique approach, but also unique features that you might want to decide which one is the best for you. But the most important part here, I think, is kind of shifting your mindset and your organization mindset from being a lot of different individual contributors that we call DevOps nowadays, to having an actual platform team that can automate and maintain things at scale and empower all the other developers to do the same. So it's actually possible, right? Right. And last thing is I'm going to invite you, if you're using Crossplane, to check out Komodor or Komodor to manage and troubleshoot Kubernetes, as I'm assuming you are using if you're here in this talk. But that's it for me.